All right. If you recall from past math classes, a function that is represented by a set of ordered pairs is going to be f of x, written as x plus 3 for set A to B, and then that's 1, 4, 2, 5, 3, 6, 4, 7. The inverse of that function, denoted as f negative 1, is to reverse the ordered pairs. So f inverse is 4, 1, 5, 2, 6, 3, 7, 4. So the basic idea and functionality of inverses are that the domain and range flip. So what is the domain of the original becomes the range of the inverse. The range of the original becomes the domain of its inverse. Therefore, composing the inverse and the original together will always give the identity function x. The existence of an inverse function theorem says in order for a function to have an inverse, the function must be 1-to-1. A function is 1-to-1 if it passes the horizontal line test. So what that means is that for every y, there is only one x. So we have the two functions, x cubed and x squared. So the cubic function is an odd function, which means its end behavior is in opposite directions. It goes through 0, 0, 1, 1, 2, 8, etc. It goes through -1, -1, -2, -8. So x cubed is in fact 1-to-1. X squared, conversely, goes through 0, 0, 1, 1, 2, 4, 3, 9, but it's symmetric, so it also goes through -1, 1, -2, 4, and -3, 9. Thus, x squared, which is an even function, is not 1-to-1. It fails the horizontal line test. Therefore, x cubed has an inverse, whereas x squared does not. There is no function that if you compose f of x and g of x that would give x squared back to x. And you might tell me that the square root does that, but it does not, because the square root of x squared is the absolute value of x, which is not x. To find an inverse function algebraically, you must first determine if 1-to-1. If it is not 1-to-1, you can make a restricted domain that makes it 1-to-1. If it is 1-to-1, then we switch the x and y's, solve the equation for y, to find the new domain and range, and verify their compositions are equal to x. So we know that x squared is not 1-to-1 without a restricted domain. So the only way for this function and this function to be inverses is to take into account that g of x is only the positive square root. Therefore, my domain of x squared has to be x values greater than or equal to 0. Now in this case, because it is shifted down 1, that does not affect my domain. If it was shifted horizontally left or right, then it would affect the domain. So 2x squared minus 1 is a quadratic function shifted down 1. So instead of going through 0, 0, it goes through 0, -1. And then instead of going up 1 and over 1, it's now stretched. So when x is equal to 1, it goes up 2 and over 1. So we have the point 1, positive 1. And if you didn't believe me, you could plug 1 in, and 2 minus 1 is 1. At 2, it's going to go up instead of by 4, by 8, because it's being stretched or doubled. So instead of being at 2, 4, we're at 2, and it's being stretched by 8, but down 1, so we're at 7. So again, the f of x function contains the point 0, -1, 1, 1, and 2, 7. So its inverse function, g, without plugging in, should contain all of the flipped points, -1, 0, 1, 1, and 7, 2. So this is really the square root function of 1/2 x plus 1/2. You could check all of those points. If you plugged in -1, -1 plus 1 is 0, 0 divided by 2 is 0, square root of 0 is 0. So -1 is in fact at 0. Similarly, if you plugged in 1, 1 plus 1 is 2, 2 divided by 2 is 1, square root of 1 is 1. And 7 plus 1 is 8, 8 divided by 2 is 4, square root of 4 is 2. Inverse functions are symmetric about the line y equals x. So if you look at these two graphs, if you were to draw in the line y equals x, they would in fact be symmetric. Is everybody okay with inverses? This is kind of like the Algebra 2 pre-calc inverses in a nutshell. So I haven't really talked about the calc part yet. So if you had to find the inverse of x cubed, what you're going to do is switch the x and y's. So you get x equals y cubed plus 2. And then you solve for y. All odd functions have inverses because all odd functions are 1-to-1. So we know this is an inverse because it is odd. We could also confirm algebraically by taking our inverse and plugging it back into the original. So the cube root and the cube cancel. That leaves you with x minus 2 plus 2, which gives you x. And again, by definition, if you compose a function and its inverse, it will always equal the identity. The identity is x. So that leads us into our exploration of finding the inverse and derivatives of a function. So if you have the line y equals 4x plus 1, what is the slope of our line? What does the slope of the line represent? Okay, what's the inverse of y equals 4x using the method from above? Perfect. So using the idea from above, we flip our x and y's, solve for y. So we get that the inverse is 1/4 x minus 1/4. So what's the slope of the inverse? Okay. So it kind of goes back to that example I gave you earlier today where the derivative was 5, and I told you its inverse was 1/5. If the original contains the point 29, what point does its derivative contain? Perfect. So if the original contains the point 29, the derivative contains the point 92. The slope of the line on the original is equal to 4. And then if it's on its inverse, it is the reciprocal of the slope of the inverse. So the difference is that the slope of the inverse is calculated using the 0.92 instead of 29. Yes, as long as it's linear. Like, I wanted you to see how they relate so that when I give you the definition on this next page, it kind of makes sense why it is the definition on the next page. Does that make sense? So using the components for the previous example, we can find that the derivative of an inverse function without actually ever having to find the inverse in calculus. So in calculus, we can have a formula where we can find the derivative of the inverse without actually ever having to find the inverse. So we're going to talk about what in the world all of that is. So f prime of x at x equals a is the derivative of f with respect to variable x evaluated at point A. And that's some notation that we kind of hit into with implicit. Like when we started the implicit, instead of like A, I had put the ordered pair, which represented the x equals and the y equals values. So now we're taking that same idea and we're using it with inverses. So this stands for the derivative of the inverse function with respect to variable x at point P. So that point P represents the y value of the original, because this is the inverse. So the x value of the inverse is the y value of the original. Does that make sense if you think about the point 2, 9, and 9, 2 from the previous example? So this point P represents the y value of the original. So it's equal to, so the derivative of the inverse at point P, which is the y value of the original, is equal to 1 over the derivative of the original evaluated at point Q, which is the x value of the original. So give that a second and we'll let that sink in. Exactly. So P is the y value of f of x, and it's equal to 1 over the derivative at Q, which is the x value of the original. So what you're doing is finding 1 over f prime at Q, which is the x value. So if you go back to the example like we just talked about with the 2, 9 and the 9, 2, what's the derivative of 1 over of y equals 4x? It's 4. So the derivative at any point is 4. So it'd be like saying f prime of 9, or sorry, f prime of 2, which is 4. So it's 1 over f prime of 2. Yep. Honestly, the easiest way to see it is in an example. All right. So here's my f of x. What's its derivative? Start with that. Perfect. So derivative is 5x to the 4th plus 2. If you're asked to find the inverse at -1, so we haven't gone to the derivative part yet, this has a typo. I need a prime. So if you're asked to find its inverse derivative at -1, that is the y value of the original point. No. All we have to do is confirm that when y is -1, x is 0. So if you plug in 0 here, what do you get? Perfect. So according to the formula on the previous page, we need to find 1 over the derivative at my x value. So the inverse derivative at -1 is equal to 1 over the derivative at 0, because it's the x value of the original since this is the y. So you have to find the derivative because you have to find the derivative at the x value from the original point. We plugged 0 into the derivative, not the original. For the first part, you're right. Yeah, you don't need the derivative for A. Correct. Correct. So we're trying to find the inverse derivative at 2, which is representative of the y value of f of x. Anytime you need to find your inverse derivative, you need the derivative of the original. So if you need to find an inverse derivative, you need the derivative of the original. So derivative of x cubed plus 2x minus 1 is 3x squared plus 2. What makes example 2 harder than an example 1 is what don't I know in example 2 that I need? Yeah, I don't know the x value. So how do you find the x value?
You set the equation equal to 2.
Perfect. So find that. You have to set 2 equal to x cubed plus 2x minus 1. So anytime you solve an equation, you get it set equal to 0. Now, here's where trig and algebra all come back into play. The roots of a function that are rational come from the values of the last term and its factors divided by the value of the first term and its factors. Remember that p divides q stuff? So the last term's factors are what? So that means the only rational zeros of this function are going to be positive 1, negative 1, positive 3, or negative 3. They're the only numbers that can play. So we know it has to be rational. So what you could do is two things. You could either do synthetic division to see if they work, or plug them in. So you could plug in x equals 1. So 1 cubed plus 2 times 1 minus 3. 1 plus 2 is 3 minus 3 is? So that works, right? We're trying to get it to equal 0. So that means that my x value, when y is equal to 2, is 1. Go ahead. You just need 1. Because all you need is 1 over the derivative of that value. So once you find 1, you're good to go. So my point is that it's, remember, it's p divides q. It's the factors of the last term over the factors of the first term. They're the only numbers you can plug in to get this equal to 0. Well, in this case it's 1. Because it's like the number 1. That's why I said it. No. So like it would be plus or minus 1. So that's why I said it was 1 or 3. Because there were no numbers. If this had a 2, yeah, it would have been. And so then your answer possibilities would have been 1, 3, 1/2. You only need 1 of them. So you always start with like, and they're usually not. It's not hard ones. Or if it's going to be difficult, then it's a
calculator question. Or sometimes they just, right, like, but you can also like look at this. I could have looked at that and kind of knew in my head what numbers.
Which is factors of first and third term, including the factors of what values of that?
The factors of the last term over the factors of the first.
Okay.
That's it.
Divide from 1 and 1 instead of 1 and the last one. And how is, oh, it's
One
1
and
just
three.
1 and 3.
Yeah. So now,
Adding the derivative.
exactly, you find the derivative at 1. So the inverse derivative.
Plug anything into the
That's what I keep saying. It's confusing because they're giving you the y value. You have to plug in the x, and the x value is what you plug in. So it's all about, that's why I really go through and try to reteach you inverses to try to make you understand the relationship.
This doesn't make sense to me because, like, in the previous example, you were putting the x's and the y's.
Because you were given the originals.
Why are we?
Because you're given the value at the derivative of the inverse. This asks you to find the inverse value. So this is like giving you the y value of the original. So 1, 2 exists on the original. On the inverse, it's the point 2, 1.
I guess it's just saying it's theoretically you could solve for the algebra for the inverse and then take the derivative of.
Yeah, do you want to
That's
find the
what I'm saying. I don't
algebraic?
want to.
You don't want, like, okay, so let's say
This saves you
theoretically,
from doing that.
you do what you do. Like, let's say, look. So let's think about how much more work. No. Here's what you're saying, which isn't wrong. But I want to show you how much work it is. So you have f of x, there's your original. So you find f inverse. In order to find f inverse, you have to flip your x and y's. So now, no, you have to do it before you can take the derivative of it. So to find that, then you have to take the derivative of that. Oh.
If you could do that, that's what you could do.
Right, but like algebraically, that doesn't work.
Corey, can you do that? No.
So like you would have to do x equals y cubed plus 2, hold on, y minus 1. Well, no,
No, you
as
can
I
do
say,
this.
you can, but you would have to take the derivative using implicit right now.
I did better on implicit.
So like it would, like this represents the inverse, so its inverse derivative would be 1 equals 3y squared dy dx plus 2 dy dx. And then you'd have to do dy dx equals 1 over, well you didn't do this though, there's a reason for my madness right now. 3y squared plus 2.
Theoretically.
So wait, what number would I plug into this? I know, but
2, 1, 5, 2.
why? And how does it,
Here's the y value in the original is 2.
It gives you the y value of x. It's fine. Actually, I did that way. It's pretty easy.
it's not 5 it works.
It's 14.
So what would you have to plug in, or how could you make it work?
with the x value.
Yes.
You still need the x because 1 over 3y squared represents the slope of the derivative.
Yeah, well, so thanks for continuing.
Now,
Well, that's not what I would have done.
Or I would just done it the right way.
I would have done the right way. But if I would have kept going and set y equals 0 instead of taking the implicit. You see, when you went x equals y
And then what?
equals 2y minus
but
1,
how? How would you solve for y?
Yeah.
Double y's.
This is why you just do it the right way, guys. To begin with.
So you're saying we don't even need to do the inverse of f because we're
No, that's the whole point.
But it's 95% of the time we don't need to do what.
So you'd still have to solve for x equals 2. And then plug that in because that would be the y. Switch. That's the way you express it. Fine.
now I'm just confused.
Well, thanks for the tangent you sent us down, guys. You're
If you
bad.
can't even
You're
plug
bad.
2 in here, it still doesn't work. I was trying to see, because the 2 has to get plugged in here. Because it's the inverse is x value.
Oh yeah, that one's better. This one's good. I mean, my mom has to go back to sit in another thing. Rewind it at 6 o'clock.
Alright. So this basically is what she just asked. Like, could you do it? Yes, you can, using implicit. You can. It's just that where everybody makes the mistake using implicit is that you want to plug that 2 in for y, but that 2 represents the x of the inverse. And everybody wants to plug it in for the y.
It represents the 2 of the original.
No. It represents
Yeah,
the y.
X of the new one.
It does. It depends on what way you're talking about.
I'll just follow your way.
So like, and this is the news for example 3. Okay. I guess what I'm
Are we
getting
gonna
at.
have to know both ways on the test? Are you gonna say do it with the implicit?
No.
Probably.
Your homework technically is set up to make you do both ways, but I don't care if you do both ways. You can do it the way we just. Do you want to know implicit or no?
No.
Okay. The only thing that you have to take into account then from this example is where the x and y's come into play.
At least they gave us x equals 1 this time, not the y. I'd rather just plug in than I would have to solve for it.
Right. Like, so if they give you the x, you solve for y. If they give you the x, you solve for
But
y.
if they're given the y,
Exactly. Exactly. So I believe.
Out of curiosity, did you technically need to solve for y? Or do we maybe need to plug that in?
Well, I did this one implicitly.
Okay.
And then I show how if you did it implicitly, you do plug in the y value
Right.
because that's like what we did over there. I did this way implicit to show how if you wanted to do implicit, you could plug in a y. But it's the y of the original.
But have we done it manually? I don't have to solve for it.
So
we would need to solve for the y.
Why?
Because wouldn't we have to write that there's a 3 variable Sure, so we don't do it. Well, technically we don't do anything. We don't close the unit.
You're finding the inverse derivative of 1.
Right.
Yeah, but we
So
technically.
why don't we just put one?
So to find the inverse derivative of 1, you have to plug 3 into your derivative. The derivative of x cubed minus 4x squared, you're not plugging 1 in, you're plugging 3 in. 1 is on the original.
Can you just do this for us the regular way?
Yeah.
No. See, that's not me confused.
Or are you in here? How about we do it?
Yeah, I was. Like, this was obviously my notes. Okay. It
I think that's easy.
implicitly?
Yeah. But why is the
We always stick to the first way that we learned. We understand.
I now don't.
so then
I don't want to learn too many ways. This is less memorization.
It depends on. No. This. I feel like this is. It depends on how they word the question.
I just don't understand why it didn't work for us. It didn't work for us.
she didn't plug in the right.
I didn't plug in the right number in.
If the original contains the point 1, 3.
No.
Use the x. But it's. That's what I was getting out of this. If the original is 1, 3, then the inverse is 3, 1. So the directions would depend on what you're finding. If it says to find f inverse prime of 3, then it's equal to 1 over f prime of 1.
No, that's what I was doing.
Yeah, that's what I was doing.
It doesn't say, it just says example thing.
It says at x equals 1.
So this isn't
It
like
just says
example
F9,
1.
but like I don't know what it's.
Because in the directions it says it wants you to solve for the inverse implicitly.
Where does it say that?
Right where it says method 2.
Yeah, I need to.
I thought I had this figured out, and now I'm actually worse than what I
I was gonna say, I feel like you guys just broke.
We took steps backwards today.
Brock, Spiker, and Maria Polito, please come to the office. Brock, Spiker, and Maria Polito, please come to the office. Also, there will be a break meeting at the library at the beginning of QRT for the following students.
Questions.
Brenda Bell, Ella Shuley, Alex Siege, Ava Gross, Cole Powich, Colleen Walsh, Eliza Chip, Alicia Olson, Avery Mollick, Molly Sheets, Alex White, Emily Johnston, Dante Shuley, and Taya Spencer. Those students, please report to the library for a brief meeting at this time.
So f prime of x, it's going to be in your book because I don't want to be able to. I just want you to find your derivatives and use the formula this way. So f prime of x is what?
3x squared minus 8x plus 7.
So the original is 1, 3. You find the inverse at 3. Then it's 1 over at 1.
Okay. That I can do. That's what I was doing all along.
So 10.
Yeah, that's what I'm doing, but now I don't know if I should be doing it for 1, 3, 7.
That answer up there was as, no, well, that was as if the inverse was 1, 3.
So when we're solving for the inverse, the value in parentheses is not the value we plug into the equation.
Hey, there's faster chemistry in this room. It's correct.
I'll see what's the homework? Is there homework? If there is, send it on